So yeah, I just want before like going to discuss on this operating systems. So let's. I just want to mention because the next week is your exam week, right? Midsem. So there is no classes, and we have a class test. We have the midsem test during that hour slot the next Tuesday, right? So the next Tuesday, whatever the 2 hours we have slot, same slot. So in that 2 hours we have the exam. The 2 hours exam starts at 10, and it will be completed by 12 o'clock. Okay, and so as I already mentioned that this test will be like a conventional test, but it's not that you have to. It's not the conventional test means that you have to write it on a paper properly with a normal pen and paper, and use the proper paper. Use the very nice clean papers and all use the white paper properly, A4 size papers, and then write neatly. And after that, once you complete that, then you scan it and send to your corresponding like your TAs. Because as I mentioned that the CA part will be taken care by the 5 TAs, right? Total you are divided into 5 groups, like approximately 50, 50, 50 like that. And for each group, there are 2 TAs will be there. One TA meant for CA and other TA is for OS. So whoever is the TA that is given for the computer architecture. So for that particular TA's mail ID, you need to send a mail. You need to send this one, the answer sheet, scanned answer sheet within like within 10 minutes of that, like by 10 o'clock it will be over. So before 10:10, you need to submit. You need to submit means you have to submit by 10 o'clock itself. So that delay will be like, no, it is like just to take care of anything, any like network delays or whatever, and also that 10 minutes itself is a very big thing. But anyway, so 2 hours is the exam, and at 10 o'clock you sharply stop that, and then you scan it, and then you send to the corresponding TA. And for scanning, and all of you are familiar, and all, all of you have smartphones and all, and there you have option that like a document scanner is there. So with that you can scan it. All the pages you can concatenate in a proper sequence. Suppose you have 12 pages you have written, for example, you take those pages successively and make one PDF file, and then that PDF file you can send to your corresponding CA, TA. Okay, and the syllabus will be like whatever we have covered till today. So that will be the whole syllabus will be there for your exam and all. And exam will be for 50 marks, and there is another exam at end sem, another 50 marks. And again, I'm not overlapping. So these 50 marks and this is CA. And for the next exam, the syllabus will be only on the operating systems and all. Okay, so that's all about the exam and all. So please prepare properly, and don't and another thing is that since it is the exam that virtually happens and also, please don't take any shortcuts or any like the small practice things and all. So if it is observed, then both will be, all of them will be penalized. Whoever had a copies and all properly, that means if it is exact copy, if I observed and all, then you will be penalized, right? So therefore, please don't think about those things. Whatever you know, you please write that. And as I already mentioned, that don't worry about the absolute marks. It will be, as I already told, it's a relative grading. So I used to follow that. So therefore, don't worry about like whether you have answered all the questions or not and all. If the paper is tough, it will be tough for everybody. If it is easy, easy for everybody. So you please try to do it whatever you know that whatever like based on your thing. Please with the proper mindset, you please try to write down clearly, and then write the paper, write the answers very clearly and all. Don't write just like that kind of a thing. It should be very systematically, nicely, it should be presented. That also matters and all. Like you write here and there, it's not that way. Properly, you take a time and properly write the answers and all. Like if it is a problem, for example, then you need to write all intermediate steps and all properly. Then only it will be given. Otherwise, just giving answer and also that's not at all tolerable, because this is a conventional exam. You have to write in detail all the things and all. Don't expect any theory questions and all. theory questions will be there, but it will be like a pointed or like 1 or 2 sentences, maximum 3-4 sentences or 5-6 sentences will be there. Don't be, it's not like stories will not be there, because as you see that the subject, the nature of subject itself is like that, right? So whatever has been asked, you please write to the point and all, and nothing more, nothing less. Hmm. So please prepare well, and don't attempt to do any copying or other things and all, like malpractice things and all. So that will be penalized, and right. So even it will be like taken to the notice to your faculty advisors, departments, heads, and all these things. And so please don't think about that one. Whatever you know, please attempt. Right? Please do that. Yeah, that's all. And yeah, the exam will be given in the. I will mail you the, not sharing this question paper in both the modes, in the like in the Teams also. I will up just before 5 minutes, like 9:55 around that time I will upload here, and as well I will also send you through email also, right? So those whoever is not able to see this, not able to access these Teams or whatever and all, whatever the reason, if you are not able to, then you can have alternatively your mail also I will send for your all role list. I will send the question paper through email also. So in the both modes I will send. So please start at 10 o'clock and then wind up by 12 o'clock. Okay, so that's all about the your exam. Okay, and yeah, tell me.
So can you
Yeah,
tell
please.
what kind of questions?
No, what kind of questions means, you see that what is the way I used to like discuss in the class, the same things used to be there. Like there will be some numericals will be there. There will be some kind of a diagrams. With the diagrams you need to explain, right? So there are like a mixture of all those things. Hmm?
Okay.
So, yeah, okay. Can you see this slide? I'm just keeping, yeah. Hello? Hello? Hello?
Yes, sir, it is visible.
Yeah, yeah. Can you see the slide? Yeah, right. So yeah, right. This is the end. So now we are starting the second part of this course. Like in CAOS, the CA part we concluded in the previous class and all, and now we just started this operating systems. And so when you look at, as I already seen, you also experienced also most of the cases in CA also, like it's not that most of the things are like they are kind of intuitive, the whatever the methods we have used, and like various techniques we have used and all. So they are appears to be like more of intuitive, and the same thing you can also observe in the operating system also, right? When you're going through the various contents of operating system, you can able to see that the various services provided by operating system, or the role of the operating system, and what it will do, how it supports the users, and how it make use of the computer efficiently. So all these things and all, if you can able to see that, it is like more of intuitive and very generic also, not much difficulty. And so that's why again you need to, but you had to give time to at least go through the text at least once, so that you can able to understand, or you can able to make the things clearer. Otherwise there will be like, if you just follow the slides and all, it will be tough. It will be tough for means actually you can understand certain things, but there will be gaps used to be there, and those gaps you cannot fill it up. You can fill it up only by going through the textbook and all. And here the slides, whatever I'm presenting, you can able to see that these slides are from the given by the textbook itself. And I'm just following the slides of 9th edition. So there won't be, it's not much difference as I observed, because I have slides of 8th edition, 9th and 10th edition are there. But when I looked at that, it's not much variation and all. It's about 5% or less than 5% variation across these 3 editions and all. So whichever the edition you have in your hand, so you can use that. There is not much variation at all. But anyway, however, whatever the slides I'm using, so those slides anyway I will upload in the Teams. So there won't be any much problem at all, right? And then coming to the Yeah, actually here in this today's lecture and then the Thursday. So in these two lectures, we'll try to cover the introductory part. That means like a broad overview of an operating system. What is an operating system and like what are its functionalities and how it supports the various activities that are related to computing system and how it is perform the how it efficiently use the computing system and how it helps the users to perform their tasks. So all these things at a very gross level we'll try to discuss, because the actual details and all we'll discuss in subsequent chapters. You can able to see these things, process management, memory management, and these things where you can able to see the details, more details like. And here in this chapter and all, a broader perspective of or the overview of an operating system, what it contains, and how do you design the operating system for a given goals and objectives, right? And in various computing environments, what is the role of operating system? Because you have PCs, you have mobile phones, and you have servers, and you have the networked systems are there, and you have embedded systems. So likewise, if you see that there are various computing environments, and in those cases, what is the role of operating system? So those things, like all these things at a broader perspective, we'll try to discuss in this particular chapter. So these are the various contents we'll come across in this chapter at a very superficial level, like at a very gross level or a thematic level. We'll try to discuss about these topics and all. Otherwise, each itself is very big in its nature. We'll try to discuss at a very gross level, and later some of these topics will go into the detail and all. Right. So the objectives of this operating, the broader objectives are like, so first of all, before going to discuss about operating system, because operating system is basically that it used to maintain the computer system, right? So therefore, to maintain a computer system hardware, so first of all, we should be aware of that what a computer system consists of, what are various basic hardware components it consists of, and how it is managed by the operating system. Because the actual hardware will perform the task, whatever the user applications, all the applications are actually implemented by the hardware, but the bare hardware is not accessible by the user or the user programs and all directly. So therefore, the operating system will play a role as an intermediary or interface between the user programs, user applications, and the actual basic hardware which actually perform the tasks and all. So we'll see that actually what are the objectives to carry out these things. So first of all, for doing that, we should be aware of that how the computer is organized. It's nothing but what are the basic components of that, how the computers are varying for carrying out various applications and all. So those things we'll try to discuss very briefly. And once if we know that, then afterwards we'll see that how the operating system will be used for taking care of various objectives or various tasks in a specific environments. For example, if the computers are networked, for example, so in that case, what is the role of operating system, right? And suppose we have a desktop PC, so where it's not network connected. So in that case, how the operating system used to be, right? And if you have a mobile phone, how the operating system used to be, right? If you have embedded system like your washing machine or some other like microwave and there also you have embedded systems, you have some devices which will be controlled by a small chips and all, for processors and all. So in that case, what kind of operating system or what is the role of operating system? So for knowing those things and all, we should be aware of that actually what are the various components of a computer system and how they will be managed. So that is the first thing. And then afterwards to provide grand tour of major components of operating system, what are various components in the operating system, and then give the overview of different computing environments as I mentioned already, right? And then to explore the various operating systems like open source and closed source and all. And here uh, so what is an operating system is actually here, as I already mentioned, it's a software, it's a program, like any other application program. It is also a program, but the objective of this program is that it acts as an intermediary between the user of a computer and the computer hardware. Because the computer hardware, it's nothing but we'll come to know we already come across, right? CPU, memory, and other devices and all, keyboard, monitor, and many other devices, network adapters, and all those things. So this is the various computer components are there, and those are the components put together will perform the desired task, right? And the users will expect the computer to perform various tasks, either to browse something or to get a picture or to send a file, to send an email or write something in the word processor and all. So all these things, the user expectations. But the basic hardware will be like the basic CPU, memory, and so on. So how does this hardware manages to perform the various user applications and all? So for that, actually, this operating system acts as an interface or intermediary, or like a kind of a middle layer where which takes care of both the things, like which takes care of the user's requirements, and at the same time, whatever the hardware was there, it can able to efficiently use, or it can able to use the hardware or like in an efficient way, so that you can able to perform the results in an optimal way. So these are the goals of operating system, like very broader goals and all. Execute the user programs and make and provide solving the user programs easier way, right? So that's a basic task of like a computer and all. Whatever the user programs that you are giving, and you can able to run those user programs, you have to execute those user programs so that the desired applications will be fulfilled. And second one is that make the computer to be convenient to use. Yeah, this is true. We have a computer where we have the hardware components are there put together, but how do you can conveniently you can use it? How to provide a user interface or user such that user can feel like very convenient to use the computer and all, like the computing system and all, right? And then the final thing is that use the computer hardware in efficient manner. It means that you have different components are there, CPU, memory, and all these things and all. And these things we have to use it in efficient manner. It means that we have to see that all these components will be used in effective way. Effective way means all these our ultimate goal is that all the components should be busy all the time, busy most of the time, so that you can say that your hardware is effectively utilized and all. Like your CPU has to be used most of the times, like, and likewise your IO devices or your memory access and all the time it should be effectively be used. You should make them busy all the time, right? So these are the broader goals. It means that to run the user programs in efficient way and to make the computer system to be usable in a very convenient way for the user, and to effective usage of the hardware and all. It means that whatever the resources are there, those resources to be, you have to be make it like available or make it busy like most of the times. Then coming to the basic components of a computer that we are already aware of, that hardware, like then the operating system. The operating system's role is that which controls and coordinates the hardware among the various application users. And then there are application programs. So by using these application programs, the user can able to access the computer so that he can able to perform his the various tasks and all. Various tasks mean at a very high level, the sending an email, for example, receiving a file or sending the file, or like accessing the like a system in using a remote login. So various applications like. So for those things, you can use some application programs. By using these, the user can able to conveniently use the resources and all, right? So these application programs, some of the examples like word processors, compilers, web browsers, databases, video games, spreadsheets. So likewise, all these are the like these are the application programs where some of them are the system programs also. There is, as such, there is not much distinction between the system programs and application programs. These will provide you the make use by made use by the user to perform various tasks and all. And finally, the users and all, like ultimately at a very high level, the ultimate the users of the computers are like a people, machines, and other computers and so on, right? Because if it is embedded system and all, the machine will be the high, that suppose you have a washing machine, and in that one of the component will be related to your computer or electronic component, right? You have a processor, memory, and so on. So the ultimate objective is that actually in case of microwave oven or like whatever, the washing machine or some other like home appliances and all, It's a broader goal, and that part of the sub task will be carried out by your computer and all, your computer related software and all. And maybe the people directly they can use, they can, the end users, maybe the directly humans or the machines or the other computers. Suppose the computers are connected to network and all, then sometimes one computer may request the other node to fetch something or to get something. So that way, so these are the four broader components, like hardware, which is the actual the components which performs the realistic tasks and all, and the operating system, which coordinates between the users and the hardware, and application programs, which some set of programs which are used by the users for a convenient use of the computer and all, and similarly the end users and all. So these are the four broader components. Yeah, the same thing here. It was mentioned pictorially. You can see that computer hardware, then operating system, and we have a system and application programs here, like a compiler, assembler, text editor, database system, and so on, whatever, web browsers, spreadsheets, and many things. And sometimes you can write your program which can be served for the multiple purposes and all, that also can be treated as an application program. And here the distinction between the system and application programs are kind of, you can say, when you say application program, I can say that the text editor, web browser, and some other databases, these are the kind of application programs. System programs are nothing but a compiler, assembler, and a kind of a loader, linker, and the other things like, for example, some file management programs like whatever, creating a file, deleting a file, all these things, and also comes under the system programs and all. As such, there is no distinction with respect to the operating system and all. Operating system both will treat both the application programs or the system programs in the same way and all, right? So all these programs will make use of the operating system to perform the task, to use the computer hardware and all effectively. So these are the four components as it was mentioned earlier in the text, and this is pictorially represented. Then what operating systems will do? Yeah, the same thing, whatever we had discussed. And that depending upon the viewpoint, because as you see, the operating system is in between the hardware and the ultimate user. So from the user perspective, operating system has to deliver certain objectives or certain goals. And from the hardware perspective, operating system has certain objectives, right? So therefore, when you say that what the functionality of operating system is, so we need to be clear about actually what are its functionalities or requirements or objectives from the viewpoint, from the user viewpoint. If you want to see that what is operating system's goals, means it has something different. And from the system point of view, it means from the hardware perspective or the basic components, what the computer consists of. From that viewpoint, it has certain other objectives and all. Like, for example, if you see that from a user point of view, you can say that user want the convenient to use from user perspective. So when I'm using a computer, I feel that it has to be convenient to be used. Like, for example, a simple thing. Suppose if you want to access a computer, there are different ways you can able to access. One way is that actually, if we have like an operating system provides a kind of graphical user interface, like the way the Windows provides the interface kind of icons and a different with that icons by using a mouse clicks and all, you can able to use the system and all. That is one way of accessing the system. There are other ways like using a command prompt, using a command window, where it provides a window. The operating system will provide a window, and in that window, the user has to like enter the commands, and if you can able to enter the commands, and if you execute the commands, and then whatever the command says, whatever the command program that command consists of, that will be run on a system, and you will get a corresponding output. So there are different ways, like the requirements of the user. So one way is that actually, if it is easier, like by using icons and a graphical way, it provides. And whereas suppose in case of mobile devices, for example, it provides the interface kind of a touch screen kind of a thing. So that will be a more convenient for the user. So it means, what I mean to say is that convenience means actually here, because that is the ultimate objective, because the ultimate user of a computer will be the users and all. So based on the users and its environment, we have to make sure that the user should feel convenient and easy way of using a computer for achieving a good performance. And the user will not bother about the resource utilization. User will not bother about resource because that is not known, that's not seen physically, that's not seen directly by the user and all, because there are several resources, several hardware components are there, but the user doesn't bother about how these components, the lying hardware, how it is utilizing, whether it's effective utilizing or some of them are not used or some of them are heavily loaded. So those things are not they are not bothered by the user and all, right? So from the user perspective, we have to see that the operating system should provide that. It should make easier for the user a convenient way to access the system and all, right? Suppose if you give something, some input and all, he expects that the output should be within a second he can able to see it. Otherwise, suppose if you want to download the file, for example, and he expects that the file has to be downloaded in the next second itself. Or suppose if you want to access some website and all, you want to see that web page should be displayed immediately. So those are the the requirements are the from a user viewpoint. So those are the requirements where the operating system should satisfy that, right? And he doesn't bother about that, like how the underlying hardware is utilizing for that, whether it is effective. Because of that, there are some other process which are running at the background may be affected and all. So those things are not bothered, are not worried by the user and all, right? We have to make the users to be happy, right? So for example, in case of mainframe and mini computer, so in these scenarios where the objective is that actually the operating system should make sure that all the users should be happy. It means because we have a mainframe, you'll be used by the multiple users. Like all the users will be logged on to the mainframe and then they will carry out their work. So in that case, the objective is that actually throughput. It means that all the users should be satisfied. Suppose there are 20 users are utilizing mainframe. It's not that only 5 users have given realistic access and remaining them, if they are delayed or if their transactions are delayed and all, then the others will not be happy. If it is for a multitasking purpose or multi-user purpose, so all the users, whoever is logged in, so they should be more comfortable and feel convenient and all. So that was the objective in case of mainframe, right? And likewise, there are some dedicated systems which are using workstations and other things and all. So in that case, actually here, the user, whoever is using a workstation, so most of the works will be carried out by the workstation itself. But there are some resources he may need from the servers and all. So in that case, actually, the operating system should make a balance that how it utilizes the resources that are there in the local machine. And at times, whenever it needs the resources or to carry out certain tasks, it may access the resources from the servers also. And for example, handheld computers, for example. So here the requirement is that the resources are limited here in case of handheld computers, right? The battery life is a very critical one. And even the process also not very powerful process, memory also limited memory and all. So in those resources, we have to see that how the operating system can manage the resources to make the user to be happy and all, right? And there are some computers where or some systems where there is no user interface at all. Like for example, you have embedded systems. For example, you have what I used to mention that example like washing machine or your microwave oven or some other thing like whichever. And there you can see that there is not much user interface. We have only that some display will be there and you have some buttons will be there or some small keyboard, which is a very minimal number of keys will be there. So with that you need to manage, right? So those are the embedded computers where, so what I mean to say here is that the operating system, that depending upon the environment and from the viewpoint, it has to manage or it has to perform its objectives and all. Like if it is a desktop and all, it has certain objectives will be there. And if it is a server, it has some other objectives will be there. And if it is there in the embedded device, it has some other objectives. And if it is in the handheld devices, it has some other thing. And if it is something like a cloud computing or like virtual machines and all, its objectives are different. So therefore, the operating system objectives means like what it will do means it depends on the viewpoint where you are looking for, what you are looking for. So based on that, from user perspective, from a system perspective and with respect to environments, it has different goals, different objectives. That's what it means here. And yeah, again, as a resource allocator, so far whatever I have mentioned here, all these things are from a user viewpoint. From a user viewpoint, so these are the things like based on environment and suppose in case of desktop system, response time should be minimum. And in case of mainframes and all the users should get a fair chance to use the resources and all. Likewise, workstations, servers, and handheld devices or embedded devices and all. So whatever the user expects, those things has to be delivered. And as I mentioned that the operating system is in between the user and the underlying hardware, right? So from a hardware perspective or from a system perspective, the objectives of operating system or operating system can act as like this: resource allocator and a control program. Resource allocator means we have several resources are there in your computer. That means you have a memory, it's a one big resource and all, where the multiple users have to share that one. So in that case, the operating system will play a role that actually how much space has to be given for each of the user or each program and all. Huh? And so that like there will be again the trade-offs will be there. If you keep more number of programs and all, again the space that is provided by each user will be less. So therefore, you need to always you have to go back to the disk and they have to bring the desired information and all. That again will be like a lot of overload or will be there because of getting the pages from the secondary memory. It takes a lot of time and all. So therefore, you should have a trade-off, like how many users or how many programs that can be accommodated in the memory and all. And in that case also like how to allocate and so all the details like that just I mentioned about the memory. The same thing about the CPU also, right? And the same thing about other IO devices also, right? So you need to manage all these resources and all, effectively utilizing the resources and all, because there are many programs will be there and these programs will be compete for the limited resources that are available and all. So in that case, we had to see that for whom to allocate, whom not to allocate. So if there are conflicting results, requests used to be there. It means that one process requests something, it holds some other thing, and some other process requires the resource that is held by this particular process, and it will not release until it gets some other resource and all. So that way, there are certain resources which are occupied by the different process, they don't release at all unless they get something else. So there are known to be conflicting requests and all. So in that case, how the operating system will manage. So all these things will come under the resource allocator, right? We'll discuss these things, how the operating system acts as a resource allocator in a different perspective with respect to different resources. Like suppose CPU is one of the resource, right? So in that case, how the operating system will play a role, how the CPU will be scheduled across multiple processes and all, right? And likewise, the memory is one of them where all process has to be shared there. Likewise, we have a keyboard. Likewise, we have other thing like monitor and different network adapters. All how they are effectively managed. That will be a part of OS as a resource allocator and all, or a manager for managing these resources. And a control program. And as I mentioned already in the just previous lecture itself, because the OS maintains or the OS will encourage to perform the multi-programming or multitasking. So in that case, multiple processes will be there in the memory and all. So when the multiple processes are there in the memory, when the process is running, the process should not access any other process. The process has only liberty to access only in its address space and all. It should not access the operating system can also act like a control program. It used to detect the errors, and if errors are occurring, so like these things can be taken care. In that case, operating system acts as a control. It controls the various process, various users in accessing the different resources and all, right? So that way, operating system can act as a resource allocator, and operating system can also act as a control program. Acts like a control program. It tries to protect the resources and try to secure the overall system from the unauthorized users and unauthorized attacks and all. So that way, this is from a system point of view. This doesn't, the user doesn't bother about this, right? The user, from his perspective, he has certain views, he has certain objectives, he has certain goals. So those are the objectives and goals of operating system from a user perspective. And from a system perspective, these are the objectives: resource allocation, managing resources, and controlling the resources. It's nothing but protecting or securing the underlying system or the overall system from unauthorized access and all those things. And when you try to define the operating system, what is meant by operating system, there is no like universally defined accepted definition. And sometimes no, when you suppose when you're purchasing an operating system, whatever the vendor sends through a CD or a DVD, you can view that entire thing as operating system. But it's not really so, right? Because it varies that depending on the what the vendor is sending and all. But basically, the operating system is the one is a crucial program, a software. It's known to be kernel, which used to run all the time, most of the times, which used to be executed by the CPU most of the times. It executes on behalf of the user programs, and sometimes it executes to perform various tasks like resource allocation and like protection, security, and several aspects and all. So the kernel is the core part, or kernel is the the crucial software. So that will be treated as an operating system. In addition to this, there are other things also will be added upon. So these things like system programs or application programs, so they also will be given along with the kernel and all. Because when these system programs are given, that means these system programs are compiled on this operating system, and these system programs will make use of the effectively make use of the operating system to perform various system related tasks. Because system programs are nothing but they are not directly, they're not part of the operating system. They are the ones which are just above the operating system, where they are kind of like a generic programs, like where we have seen like examples like compiler, right? Compiler, like on its own, it doesn't need anything, but actually to perform the any application programs to run and all, so the compiler will be used to translate the high level languages to the like whatever machine language and all. So likewise assembler, likewise the linker, loader, and the other things like for example the other programs the file related activities and other programs and all. So which are very frequently used by the application programs and all. So in that case, you can will sometimes they will be provided along with the kernel and all. The kernel is the core part of the operating system where it meant for the applications, meant for the objectives I have mentioned just before that. And again, the application program. And again, as a kernel, it will not distinct between whether it's a system program or application program. Based on the nature of this, we'll say that yeah, this will be come under the system program, and these are come under the application programs and all. Otherwise, both are from a viewpoint of operating system, both will make use of operating system services to perform various applications and all, various tasks, right? As I mentioned, like compiler, assembler, and those are the very generic things. And likewise, a web browser, like a spreadsheet or like a Word, like a text editor kind of a thing. So these things are used for like if you want to write a program and all, you need to use the editor and all. You will use the editor to type and to make the text, enter the text into that, right? So that way, like these system program, application programs, they make use of operating system, right? Yeah, then first of all, actually here, how the like operating system will be executed, will be coming to the picture and all. Like will be actually started when the computer is run, when the computer is started. When suppose when you power on the system, when you power on the system, the first thing, because the operating system is the whole the entity that used to manage the whole the whole computer and all, right? So therefore, first of all, and again, that operating system is again a software, is again a program, right? And that also has to be executed by the CPU and all, right? So therefore, here when you start the computer, that means when you just switch on the power button on a computer, So the initial things that happens is that like this is the way there is some program known to be bootstrap program or a boot. Might aware of that. So this bootstrap program is a small piece of code. It is presented. It is available in the ROM. That is a read-only memory or known to be EEPROM. And whenever the power is on, immediately the first thing that happens is that so the contents of the ROM will be read by the hardware, and it will be placed into memory. And these contents, the whatever the contents that are there in the ROM is known to be bootstrap program. It's a small piece of code, and that will try to initialize the various aspects of the system and all. Initialize means computer have a CPU that it will whatever the registers are there in the CPU and all, it will initialize the registers of CPU, and then it will load the operating system into the operating system kernel into the main program, because otherwise the operating system it's a huge in size, so the entire operating system may not be present in the main memory and all. So it will be first basically it's there in the disk and all, and whenever you start the system, whenever you powered on the system, at that time there is a bootstrap program. It's there in the ROM, read-only memory. That means it's a memory where from this memory you can able to only read, you cannot write into that. So this bootstrap program will be first loaded and into the memory, and then this bootstrap program will be starts executed by the CPU and all. So in the process of its execution, the bootstrap program, what it basically do is that it will initialize the various aspects of the system, like device drivers. It will initialize the device drivers, device controllers. It will like initialize the registers into the device controllers, device drivers, and then the other aspects like it will then afterwards it has to load the operating system into the main memory, and then starts execution and all. And then that means when you powered on, the what you will get actually you can able to first thing is that you say the system is booting or something. It's nothing but the bootstrap program is executing, and then in the process of execution of bootstrap program and all, the various aspects of a system will be initialized. That means different registers and different other things, whatever need to be initialized. So they will be initialized. And afterwards, the operating system will be brought into the main memory. It's not the entire one. The basic modules, whatever is required, that will be brought into the main memory. And then the operating system will run its very first initial one, so that it provides the interface. If it is a Windows interface, it provides a Windows interface, whatever the basic interface, whatever is there, it provides on the screen so that the user can start now doing whatever. If we want to open the command window, he will open the window and then he will enter the commands, he will run the commands. Otherwise, if it is a Windows platform and all, so then the operating system will provide the graphical user interface. So with the mouse will appropriate icons will be clicked. So with that, will the user starts using the program and using the computer system, right? And this is the overall organization of a computer system. There is nothing to explain here. You have a CPU, one or multiple CPUs will be there, right? And you have these are the hard disk, and these are the other components like a keyboard, printer, display, and so on. And you have a main memory. So here you can see all of them are connected through a bus. There is some connecting wires are going to be bus and all. So CPU, and you can see that all these devices, including CPU, so they are connected through a bus and they are connected to the main memory. That means all will access the main memory through memory. All these things will share the information and all. Suppose the CPU want to access the disk, want to access the contents of a disk and all, it will not state, it will not access directly the disk and all. It will access, it will provide, it will initialize the disk controller, and then the disk controller will bring whatever the information that is required, that is present in the disk, that will be first of all, that will be loaded into the buffers of a disk controller. Then afterwards, this data, whatever is there, that will be passed to the main memory, and from that main memory, the CPU will access. The same way, keyboard also. Like suppose you want to enter something, when you enter that, so the USB controller or a keyboard controller, whatever is there, so the entered data will be first stored in this buffer offered by the USB controller. Then afterwards, from this buffer, it will send to the corresponding memory locations and all. Likewise, the graphical card also, the monitor also. Here the monitor, it's a one way. Like suppose you want to display something based on the CPU instructions, the data that is there in the memory, so that will be given to the this graphics adapter card, and with that it will be displayed over the monitor and all. So you can able to see that here all these components are connected to a bus, and each component or each device has a device controller will be there, has a device controller, and this device controller acts as it controls the specific device, because otherwise the CPU will not know about the nature of a disk, the nature of a keyboard or printer and so on. So each device is managed by its controller, and the CPU can access these controllers using the operating system. The operating system again here, it contains the device drivers appropriate to each of the device. And suppose you have disk controller, to talk to the disk controller or to manage with the disk controller, there is appropriate disk driver. The device driver will be there, supported by the operating system and all. Likewise, for the USB controller, that means there are mouse or this whatever it is. So for these devices to manage them, you have a device controller here, and to talk to the or to interact with the device controller, you have a corresponding device driver will be there, supported by the operating system. And likewise, the display also, graphics adapter card. And for this is the device controller corresponds to monitor, and this device controller used to interact with the device driver offered by the operating system. So with that, the desired task will be performed. Likewise, the memory also have some memory controller will be there. So likewise here, for each device, there is some specific device controller will be there, and this acts as an interface to the CPU, to the computer, from the using the operating system. The operating system will provide various device drivers. So each device driver used to manage the specific controller, and also with that, these devices will interact with the system, and the CPU will interact with these through the operating system using the specific device drivers and all. So those device drivers will talk to the corresponding device controller, and with that, the desired information will be either sent or will be received from the device and all. So yeah, and yeah, we'll stop here. And here the way it will be done, I just mentioned over here. You can see all IO devices and CPU can execute concurrently. Yeah, as I mentioned here, you can see here we have a CPU, we have IO devices are there, and they can able to run or they can able to execute concurrently. It means that the CPU can able to execute instructions like arithmetic instructions, logical instructions by using ALU and all inside, right? And these device controllers and all, the devices and all, they can also run concurrently, because device controller is nothing but a specific chip or a specific processor which has its limited task. It's like, for example, getting a data from a disk or sending the data to disk and then managing that how much data has been received. So for this limited task, you can have some processor will be there, specific processor which used to manage these limited tasks and all, right? And what I mean to say is that these device controllers are the devices and these CPUs, they can run parallelly. The CPU can able to run its instructions, and the device controller can able to transfer the data to memory, or it can receive data from memory. All these things can do concurrently. But if they want to use the bus and all, then they have to coordinate, because the bus is common. Suppose CPU want to use the bus to access something from a memory. At that time, the device controller cannot use the memory, because for all of them, you have the same bus used to be there. There is not like each of them are connected pairwise. It's all of them are connected to the same bus. So therefore, when they want to use the bus, then they should coordinate, like which one has to use it, and all that has to be decided by or managed by the operating system and all. Likewise, each device controller has a local buffer, as I mentioned. CPU moves data from and to the main memory to the local buffers, because whatever the data that has to be accessed by the CPU, it will access only through main memory. It will not access through the different devices and all. So whatever it want to access, whatever it want to receive from the different devices and all, first they have to brought it to the main memory, and from that it will access. That is what here. And IO from the device is a local buffer controller, and we'll see that the device controller informs the like here how the communication between the devices and the CPU, how it will be carried out. So that will be done by using interrupts. You have seen this word. We come across this word in the when you are discussing about the data paths and controller in the processor. At that time, at the last topic, we discussed about the exceptions and interrupts and all. Exceptions are basically like they are the events, like undesired events that occur through a software, or when you're running a program. If suppose the overflow occurs, or if a division by zero occurs, or if instruction which is not present in the MIPS set and all. If they encounter, it will generate some exception, and the corresponding thing will happen. A similar things like when a device needs a service, or when device needs some service or certain thing to talk to the CPU or to perform certain thing, at that time device will send the signal to the processor, and those signals will be treated as like interruption. That means they'll try to interrupt the current execution of a CPU, and they inform that they need something, right? They need some service, or they have to perform certain things. So these things will be carried out by using interruption and all, right? So anyway, we'll discuss later about what are these interrupts, how these interrupts are handled or serviced. So these things we'll discuss a bit later and all, right? So we'll stop here at this point. Let me close the presentation. Okay, and stop the recording.